Euclid, Book 1, Proposition 21. Alright, this is a complicated proposition, and I'm going to put it in two parts because it is that complicated. Alright, so let's start with this. You're going to start with a simple triangle, A, B, C. And then Euclid wants you to draw a line from point B to some point in the center of ABC, which is point D, and then he's going to have you draw BD and DC. And then he's going to have you extend BD out to point E. So now you've got three more triangles, ABE, BDC, and CED. Now, what he's wanting you to prove is that if you added the length of BA and AC together, you would have a greater length than BD and DC added together. Okay, how does he prove this? Well, the first thing he does is he goes back to proposition number 20, and he says that the length of BA plus AE is greater than the length of BE. And that's true. Alright, then he says we're going to add the length of EC to both BA and AE and to length BE. This is where you have that adding the same amount to both sides of an equation. Just remember your scale, alright? I've taught this many, many times. You have a weight scale like this. I'm going to draw this down here like this. You have a little platform. You have this little, like that. You have a little tray. Alright. Let's see. There it is. Okay, as long as you add the same amount, this is a pair of scales, as long as you add the same amount here as you do here, then the weight scale is going to stay balanced, just like this. Same deal here. We're going to add the length of EC to both the length of AB plus AE and the length of BE. And if we do, then we can say BA plus AE plus EC is greater than the length of BE plus EC. Because we've already established that the length of AB plus AE is greater than BE. We've already said that. Alright, now we can go one step further with this. We already know that the length of AE plus EC is AC. Therefore, the length of AB plus AC is the same as, or is actually greater than the length of BE plus EC. We've established this now. Alright, now we have to go to another triangle. We now can say that CE plus ED is greater in length than DC. Alright, now if we add DB to both CE and ED, and we add the length of DB to DC, then we can actually say that CE plus ED plus DB is greater than the length of CD plus DB. We can say that. And now that we've said all of that, since we already know that this length plus this length here, and this length here, is greater than this length here plus this length here, and this length here is just a part of this length here, and we've already said that this length here plus this length here is greater than this length here plus this length here, then it just goes into the transitive property where we can actually say that AB plus AC is greater than CD plus DB. And if you want to check it out for yourself, that's great. This is the first part of proposition number 21. Stay tuned for the second part.